Don't criticize me here, please. Yeah, that row. Hey guys, Adam Tarnowski from Flex. I'm responsible for Flex and cloud solutions, and we are in a great cloud show. So let's kind of give you a short description about Flex, what we do and who we are and why we're here, and then show you some solutions. So Flex has been in cloud business for several years. As you can see, cloud business is $2 billion business for Flex, and we have a unique view into the future and unique view of the whole infrastructure, and we totally understand who is doing what and where because of visibility and our engagement with all the key customers. As you can see, we go from mobile to medical, automotive, and any vertical, and we can connect the dots fairly easily and apply them to cloud. So this is more of a commercial about who Flex is, $26 billion company, 200,000 employees. And I'll go more into how to engage with Flex and why you should be working with Flex. So there are many different ways of working with us. You can start from integration CTOs. You have your favorite OEM, ODM that you're currently working with. We can pick up that platform, test, validate, integrate, deploy in your data center, and own this product. So you'll be talking to us directly. We own it. You don't have to go talk to your ODMs, and many of you don't want to spend time on the phone with Taiwan or China. We can do that for you. And then you can progress, or in conjunction, you can do several other things. You can do line modification or heavy customization. We can design, manufacture backplanes. We can stretch the chassis, make it shorter, add drives, remove drives, and all those things are Flex capabilities. And then if you have a specific unique need and you have something that you want us to design and manufacture, we can also do that. We can fairly easily pick up your napkin drawing and make a motherboard out of it, and make a chassis out of it, make a power supply out of it, and put it all together as a server and be turnkey server from Flex and a solution from Flex, which will stand fully behind. And that could be specifically designed for you, where you own the IP, or you don't care about IP or manufacture for someone else. So there's somewhere in between, there's a happy medium, and each one of you as our customer, and guys that probably work with me in many previous companies, you can start in as light as you want with an OEM, ODM box, or as heavy as you want. You can go all the way into turnkey manufacturing and design. And we have quite few design engineers based in Taiwan that are ready to take on any challenge. So let's jump into what Flex can do for you on the cloud, and as far as deployment partner, why you should consider Flex as your partner. The main reason is that we have global footprint. We have the same capabilities at many different locations. We can replicate it globally. So you can come into our Milpitas facility here in California. We'll do NPI, we design, we develop, and then we can replicate that all across the globe. And you get the same quality, the same interaction as you'd have gotten it here in California to support your global footprint, your global data centers. Here's a slide that kind of shows our global footprint, and this is cloud specific. This is not all 130 or so global locations, because each location can do certain things. This is more of integration, rack and stack, supporting cloud business. So we can help you avoid some of the tariffs. We can integrate in Mexico and bring it into US and do substantial transformation to help you with your tariffs. If you are purchasing something from your OEM, ODM in China, we can also move any direction in Europe and so on, and support your platforms, support your data centers, and support your customers or your data centers. I want to jump in briefly into a few compute solutions that we have here. And I'm going to go fairly quick with this. All of those platforms are at our booth, which is right over there. Recommend you stop by. We are heavily invested in AMD today. We have several platforms that are ready for deployment. This is the first platform, One U Twin, that is actually right on display in the Flex booth. It's EPYC processor, Rome ready, tested and validated for Rome when Rome comes out. And I believe this will be the most popular platform on the market going forward. The same thing to you, quad node. Some of you want more density, more drives. There also will be a bit denser platform. Single processor, more of the less of a compute heavy, more storage, NVMe SSD platform that's also in our rack. You can come check it out. And then we'll go into deep for you, 4 PCIe, full length, full height card support. That's also in our rack right on the bottom. This is One U NF1 storage platform, and this is extremely dense platform. It's 36 drives that it supports. It's very easy to miss it because it's very small, but it will also have it available. It's also Rome ready. So as you can see, we are Rome ready and ready to roll. And they say that road to Rome leads through Milpitas, actually, believe it or not, because we have everything here ready to go. Lastly, I want to touch base about Open19. You guys seen presentations of Open19 and our involvement. Flex was designer and is the manufacturer of Open19. Here you can see cages and there are 12 and 8U, a brick, which is currently Skylake right now. AMD come down the road, and also network switch to support it. So if you want to see Open19, you can come to our booth. We can show you the units, or you can go to LinkedIn's booth. We also have our servers there. With that, I'd like to bring Ram from AMD here to back me up. There we go.
All right. Thank you, Adam.
Thank you.
Thanks for giving us the opportunity to participate in your session. Hi, everybody. I'm Ram Pedibotla. I'm in the server group in AMD, and I wanted to give you a quick update on AMD's server processor roadmap and the value that we are driving to our customers. When we think about our server processor roadmap and technology strategy, we really start with what the end customers are doing and what the workloads are that are being deployed on these platforms. And we take a very comprehensive look across the market segments and the algorithms and the workloads that are being deployed on these servers. So starting on HPC through the cloud-oriented workloads, AI, AR/VR, software-defined infrastructure, and big data analytics. If you look at across these various segments of the market, the one thing that is inherent under all of that is high performance. And high performance is kind of the guiding principle for how AMD defines its server roadmap and really percolates how we think about, build, and bring to market our server CPUs. And when we think about high performance in the context of the modern data center, these are the 4 key tenets that kind of jump out at us. The very first is really doing more cores, essentially putting more processing elements into a piece of silicon. So we're able to get more throughput performance. And then you need to couple that up with enough memory capacity and memory bandwidth. So we're able to feed these cores and then surround them with enough I/O so we can move the data in and out. And underlying all of that has to be security, that you're confident that your processor is actually secure. And we deliver all of these through the EPYC 7000 series that's currently in the market. We are at the top of the stack. We have 32 cores. It's the highest core density server CPU in the market today. We have 8 memory channels, the highest memory capacity as well as memory bandwidth, 128 PCIe Gen 3 lanes, which is phenomenal I/O capability in terms of being able to attach peripherals and able to get NVMe type high-speed storage attached to your servers. And underneath that is security. We have critical features like secure memory encryption and secure encrypted virtualization to protect your data and to isolate the guest VMs when you're in a multi-tenant type environment. When you take that and really look at the density, leadership in core density and memory capacity, bandwidth, and I/O, what does that really mean? It really means that we deliver leadership performance at every price point. So if you look at the EPYC 7000 series and compare it to an Intel Platinum, let's say 8160 Skylake processor, we're 20+% better from a performance per dollar point of view. If you compare it to Intel's Gold line, let's say a 6130, our 7401 EPYC is about 30+% better from a performance per dollar point of view, and that goes all the way through that product stack. And that translates to a total cost of ownership benefit to our customers. In essence, our customers can do more with less with an AMD EPYC 7000 series processor. We're taking that kind of foundation and really able to drive to the industry. And as you can see on this chart, there's tremendous momentum around EPYC 7000 in the market with cloud providers like Amazon, Microsoft, Tencent, and Oracle, with HPC, like Lawrence Livermore National Lab, with OEMs that address the heart of the enterprise, Dell, HPE, Supermicro, and then HPC targeted OEMs like Cray, all having products that are available in the market today. Going into the next generation, we take that same philosophy and we're applying that to our next gen processor called Rome. Rome includes a new core, that's Zen 2, which has IPC improvements going from the Zen that's available in EPYC 7000 series today. And we have a modular design of really combining that with the memory and I/O integrated into a single I/O die, along with the chiplet CCDs, as we call them, that bring together the overall Rome SoC. And all of this is implemented through industry-leading 7-nanometer process technology, which helps us to deliver better density, better performance, and better power. And if you put all of that together, Rome is the world's first 7-nanometer server CPU that delivers leadership in terms of core density, increased IPC, leadership in terms of throughput compute, I/O capability, and memory bandwidth. And when we look at, one of the things I want to double click on is the implementation of our I/O capability in Rome. Rome is the first server CPU that implements PCIe Gen 4. Going from EPYC 7000 series to Rome, you go from PCIe Gen 3 to Gen 4, 8 gigabits per second to 16 gigabits per second. That is a doubling of your I/O capability. It's an incredible benefit in terms of faster attach for I/O and lower latency when you attach NVMe storage, or when you have accelerators for something like deep learning, or for kind of a warm storage kind of applications. When you take all of that and look at what is the benefit that Rome drives to the end customer, at a socket level, Rome delivers 2x the performance compared to our previous generation, looking at the integer performance. So as we said, we went from 32 to 64 cores. We went from, we have the same memory channels, but higher memory speed. We have the same number of PCIe lanes with the next gen in terms of PCIe technology. So it's increased number of cores, increased IPC, increased number of, increased memory bandwidth, and increased I/O throughput. And that drives the 2x improvement that you're seeing from integer. When you look at floating point per socket, we actually doubled our floating point data paths from 128-bit to 256, going from EPYC to Rome, and we doubled the number of cores. So that's 2 times 2. You have a 4x jump when you go from Naples to Rome in terms of our floating point capability, and that is an astonishing gen-to-gen jump. So when you look at going from EPYC 7000 series to Rome, we are delivering head and shoulders performance improvements, both in terms of integer performance and floating point performance. And we're just getting started with our roadmap. Stay tuned for Rome. Thank you.